All right, good afternoon, everyone, and welcome to our USEA Consensus webinar, the Clean Hydrogen Future Coalition, moderated by their president, Mrs. Shannon Angielski. So for those of you who don't know me, I'm Michelle Littlefield, Program Coordinator with the United States Energy Association's Consensus Program. Just a little note about us. We're formally named Building Consensus on Carbon Capture, Utilization and Storage, and Clean Coal Technologies. We call this Consensus for short. This is a cooperative agreement with the Department of Energy, Fossil Energy. The program seeks to educate the public, policymakers, industry, and stakeholders on CCUS and clean coal technologies by hosting webinars, along with a series of monthly educational briefings, conference workshops, technical reports, and we release monthly news clips of CCUS and clean coal related updates. If you'd like to join our mailing list and have not done so already, please feel free to send an email to the address at the bottom of your screen and we'll add you as a subscriber. At the end of the session, we'll have a question and answer portion. Please use the Q&A box at the bottom of your screen to submit a question and we'll address as many as we can. This webinar will also be recorded and posted on our event page along with the presentation slides, but we appreciate you taking the time to join us anyway. Although she couldn't join us today, we do have a pre-recorded introduction of our acting executive director, Ms. Sheila Hollis. We'll let her take it away.
Hello, I'm Sheila Hollis, the Acting Executive Director of the United States Energy Association. Just a moment about what the United States Energy Association does and why we are deeply involved and very committed to the Clean Hydrogen Future Coalition and all that it's going to do. The United States Energy Association has been around about 100 years. We've worked in 104 countries, all in connection with our relationship with USAID, the State Department, and the Department of Energy. We are working in a variety of forms of energy, and certainly the clean hydrogen effort is something we're very, very excited about. The Clean Hydrogen Future Coalition is a diverse support group to spearhead clean hydrogen in the energy future of the United States and deep decarbonization. Decarbonization is incredibly important, and it will, we believe, have a future in impacting in a very positive way jobs to infrastructure and all points in between. The coalition's clean hydrogen ecosystem will adopt hydrogen in all forms of energy production, with transportation, electricity, industrial processes, and energy storage markets to scale away from carbon-intense production and support U.S. action in global competitiveness. Today, we will hear their motivations, action plans, and visions for this hydrogen future in clean energy, parallel to President Biden's Build Back Better plan from coalition leaders in the industry. It's very exciting. We're into new territory, and we're prepared to help and support the efforts in this arena. And we very much enjoy you joining us today, and thank you very much for your interest and participation.
Great, thanks. And let me just start off today by saying, first of all, thank you to USEA for the invitation to provide this briefing of the Clean Hydrogen Future Coalition and why we came together and what we're doing. To get us started, I'm going to turn it over to Eric Mason, who's the chair of the coalition, and he's also the global head of energy supply and trading for Nikola. So I will turn it right over to you, Eric.
Thanks, Shannon, and thanks, Michelle, for having us today. We appreciate the opportunity to speak to you and those who are on the call. We really brought together the Clean Hydrogen Future Coalition in order to develop a principle that we needed to create a supply of clean hydrogen through all different pathways of production that will provide a critical pathway for our organizations to meet decarbonization objectives and transition into a clean energy economy. Our coalition really is here to support policies that will help to develop the full value chain of clean hydrogen, which includes all forms of production, all modes of transportation and delivery, and all end use applications that are going to be necessary for clean hydrogen to scale and become economic. Our members reflect the diversity of the value chain, including representatives from electric power, industrial, and transportation sectors that will use clean hydrogen as a fuel source or a feedstock. We have members who are producers of all different forms of clean hydrogen, distributors and storage operators of clean hydrogen, technology developers, equipment suppliers, research organizations, labor unions, as well as non-governmental organizations. Our coalition's approach to policy is to be colorblind and be agnostic to the technology that's being used to produce hydrogen, and really focus on the value of the integrated approach that pursues the best economic and environmental outcome. Our intent is to avoid any political polarization that this national dialogue will start at the outset of this new hydrogen revolution. And this is why we feel that our coalition benefits from a diverse group of members. For example, we've recently had a couple new members join ENGIE and the American Gas Association, who really show the diversity of our membership and are going to help us, together with others who join us, to move this market forward. Back to you, Shannon.
Great. Thank you, Eric. So the format of our meeting today is going to be in a panel format. So the first panel, as noted on the agenda, is going to start with talking about that diverse value chain that Eric has already described, in terms of that being the focus, one area of principal focus of our group. So what I'd like to do is introduce our panelists. First, we'll hear from Phil Cochran, who's the Senior Director of Government Affairs at BP America. He's going to talk to us about all forms of hydrogen production and what the coalition is evaluating there. We will then hear from Brian Lavinka, and he is the Director for Emerging Opportunities and Corporate Strategic Development at the Williams Companies. He's also serving as the Vice Chair of the coalition this year. And he'll be talking about how we anticipate moving hydrogen as well as storing it. And then we'll hear from Dr. Joe Hoagland. He is the Vice President for Innovation and Research at Tennessee Valley Authority. And Joe's going to speak to us about the variety of end-use markets where decarbonized hydrogen can be used. So I'm going to turn it over, Phil, and allow you to go first. And let me just note before I do that I know, Phil, you need to leave at the end of this panel, but just wanted to make sure that folks know that. So if they have questions before you do, that they are sure to ask them. So I'll turn it over to you, Phil.
Great. Thank you so much, Shannon. And I think Eric did a really good job at kind of setting the scene. And, you know, BP, we're a large international oil company, but our ambition is to become a large international energy company. Our focus is to get to net zero by 2050 or sooner and help the world get there. And we're scaling up our business, our low carbon energy business, looking through a tenfold increase in our investments by 2030. And that we believe that hydrogen and CCUS have a huge role not only to play in the ambition, but also in the global energy transition. We're also a leading operator of onshore wind. We've announced a partnership with Equinor in the development of 2 offshore wind projects off Long Island, and we're developing solar power projects through our 50-50 joint venture, Lightsource BP. And all of this fits so well within the framework of the CHFC. So as you think about how we currently make hydrogen, it's primarily through something called steam methane reforming. And about 95% of the world's hydrogen is made this way. It's used primarily in industrial processes and at refineries. In a simplistic way, steam methane reforming uses high pressure steam and a catalyst. It separates the hydrogen atoms from carbon atoms out of methane. It produces hydrogen, carbon monoxide, and carbon dioxide. The carbon monoxide goes through an additional treatment process, more hydrogen is produced, and carbon dioxide is emitted. What we are advocating for is clean hydrogen. And clean hydrogen can be produced in a number of ways. First, and perhaps the most simple, is by adding carbon capture technology to the SMR process. That way you produce hydrogen with a very low carbon intensity. And instead of being emitted, that CO2 is captured and permanently sequestered. But there are other pathways as well. Electrolysis, which is a process that uses an electric current that splits hydrogen from water. We use an electrolyzer for this, and it can be powered by electricity generated from renewable power, nuclear power, or fossil fuels with carbon capture technology. There is a third process that clean hydrogen can be produced by, and it's called gasification. And it uses high temperatures and pressure, controlled amounts of oxygen, and that gasification converts the organic or fossil fuel materials into end products that are hydrogen and carbon dioxide. Gasification utilizing fossil fuels, biomass, and including CCS can actually produce a net negative carbon intensity clean hydrogen. So those are kind of the three major building blocks. I'm going to throw it now to Brian to talk a little bit further here.
All right, thanks, Phil. Phil touched on a number of different ways to make hydrogen, and that's definitely a critical part of the value chain. At Williams, we're very focused on, once you produce it, how do you get it to market? Just to give you some background on our company, Williams is a large-scale natural gas infrastructure company, but I would really qualify us as an energy infrastructure company. And we think moving forward, as the energy transition continues, the existing assets that are in the ground are going to be really a critical piece of how we continue to decarbonize. We've set our own goals as a company to reduce our emissions, similar to what Phil laid out with BP. We have a near-term goal of 56% reduction in our own emissions by 2030, and then ultimately a net zero goal by 2050. And in order to achieve that, we formed a new group within our organization focused on emerging opportunities, and really looking at, what can we do today, kind of right here, right now types of solutions, and then also looking forward, how do we set ourselves up to be successful in achieving our goals, but also being able to provide those types of solutions to our customers, many of whom who have similar aspirations. And so hydrogen, and specifically clean hydrogen, is definitely a key focus of ours as we think about ways to cost effectively decarbonize the grid and do it in a way that utilizes existing infrastructure to really facilitate that economy developing. One of the big challenges that we've seen, or focus areas we've seen, has been production of hydrogen and end use of clean hydrogen, but really there's not a lot of focus on what goes on in between and how do you move those molecules from where they are most cost effectively produced to ultimately where the demand is. And we think our infrastructure is very well situated to provide that exact solution. Our connectivity to demand, whether it's power generation or LDCs delivering gas to homes or industrial uses, or into storage facilities that are already a part of our asset mix, we think is going to be a critical part of unlocking the potential around clean hydrogen. I'll talk a little bit more about storage because I think that's a really critical part of specifically how do you create long-term batteries, if you will. The ability to store hydrogen over long periods of time and have that energy available and abundant is really a differentiator, we think. And so being able to utilize assets that are in the ground, being able to provide those types of solutions to our customers to not only decarbonize the US, but decarbonize the globe is really a focus. And so we're trying to make sure that we're being as efficient as possible in terms of how we repurpose or restructure, understanding the technical aspects of what does a blended hydrogen product look like, what are the end use impacts, and also what are the impacts to the integrity of the assets that we have. And so a lot of work right now focused on pilot level projects. How do we prove these concepts? How do we start to develop these technologies in a way that brings them down a cost curve and ultimately, develops a clean hydrogen economy? We think jumping from where we are today to 100% decarbonized answer is probably very challenging, and we think there's a much more natural way to do that through the use of blue and green hydrogen. And so we're very excited to be a part of the coalition, very well aligned with kind of our goals and aspirations, and love the diversity of the group that we have, who are all trying to row in the same direction. Again, we think infrastructure is really a critical piece of the puzzle here, and we're happy to continue to evaluate ways to bring hydrogen to market. So with that, I will stop and turn it over to Joe.
Good afternoon, everybody. You know, as both Brian and Phil have talked about, I think the production of hydrogen, the storage and transportation, and then the utilization of hydrogen are all pathways for us that are very important, and that we feel will be critical for us as we get to sort of a zero carbon future. TVA is the largest public power utility. We're government owned. We're all self-funded. And we have a balanced generation portfolio. We have coal, gas, nuclear, hydro, wind, and solar. And we're currently operating about 60% carbon free with that portfolio. We expect by 2035 to be close to 80%, and that'll come primarily from retiring coal plants, building more solar, building some transitional gas, and additional batteries. But we're striving to be net carbon zero by 2050. And we really think to get there, you know, there's a lot of sort of work that needs to be done. And we're focused, you know, in a few areas. We still believe nuclear is important. We need long duration storage, similar to what Brian was just talking about. And then carbon capture, electrification, and alternative fuels, we think are very important. And alternative fuels, our focus is really on hydrogen. And we're working in all of these areas, both in projects that we have and with the industry. We're involved with the EPRI GTI Low Carbon Resource Initiative, where they're looking across the world to find out what the best technologies are. But if we focus just for a minute on the hydrogen itself and the potential that it has, as Phil mentioned, you know, producing hydrogen can be done in a number of ways. We're looking to be able to utilize our ever greener portfolio of electricity to be able to support that production. But then once it's produced, the question becomes, well, then what do we do with it, right? And how can it continue to help reduce that carbon footprint? We think, first of all, from a TVA perspective, we can use it ourselves, right? So potentially it's a fuel that could be either blended or used directly in combustion turbines or combined cycle power plants. You know, there's the growing, I think, potential for large scale fuel cells as that technology matures. That particularly coupled as hydrogen for storage, I think could be useful as we continue to decarbonize our own footprint. At the same time, we're also looking to what can we do more broadly out into the economy. You know, part of our electrification efforts at this point are focused on electric vehicles and trying to put electric vehicle infrastructure out and make it available for that growing segment of the market. But when you think about electric vehicles, that generally doesn't count heavy transportation. And hydrogen is one of those things that can be a fuel source, both because of its energy density and its ability to be stored and transported to support things like large trucking, ships, trains, aircraft, and our being able to produce it and then being able to provide that to the transportation sector can significantly help in reducing the overall footprint for the economy. And so we're very interested really through the whole supply chain of hydrogen and how it can be applied. I'm really excited about the coalition because I do think one of the challenges we have in front of us is being able to produce it, store it, manage it, and use it at scale. And it's a very large scale that we're working for. It's not that hydrogen isn't being used today, it is all over the world, but at the scale and the cost that we need to get it, it's really important that we all work together to be able to create that complete supply chain and create a market in which the forces can operate in a way that makes it cost competitive and effective. So I really appreciate the opportunity to be here, and happy to answer questions. And Shannon, I think it's back to you.
Great. Thank you all for that overview. It's much appreciated. And want to be sure that for any of you that have questions, that you go ahead and post them in the Q&A, please. I guess maybe I'd just like to start briefly with a question for Phil. Phil, you talked about, SMRs with carbon capture and electrolysis that can be done with any source of electricity, renewable, nuclear, or fossil fuels, quite frankly. Can you talk a little bit about biomass or co-firing biomass and what we're looking at there as well?
Sure. At the end of my my part, I talked a little bit about gasification, and that would be the process by which biomass or co-fired biomass would be pursued. The nice thing about that is, if you think about it, biomass is just often just emitting. It's rotting trees. It's things that are just producing emissions that impact our environment. And what we're doing is, by capturing them and putting them in this process, you actually get to a net negative impact, because not only are you reducing those emissions, absolutely, you're actually creating hydrogen, which is the clean fuel, and capturing any of the emissions associated with that process and permanently sequestering them. So as things evolve, that is actually a really exciting part of how we can move forward in the clean hydrogen space. You're on mute, Shannon.
Thank you. There was a question that did come up about the costs associated with various methods of producing low carbon or net negative carbon hydrogen. So are you in a position to speak to that?
Well, I'd be way out over my skis to give real specifics, but I would point out one thing, and that is, currently today, 95% of the hydrogen is produced using steam methane reformation. That's the process. So that speaks to what is the most economic in current space. But I think there's a tremendous amount of work being done on all of these things, as well as we look at policy evolution and how things might be incented. I think all of those will compile to a result that will say these technologies will develop down the road. And we think all three are viable. And clearly one is because it's being used, but there is more to do. And that's what the strength of this coalition is. It brings these parties together, and it helps kind of advance hydrogen more broadly and the technology that's needed to come along.
Great. Thanks, Phil, for that. Brian, this is probably a question for you. What has to be done to make natural gas pipelines 100% hydrogen capable? Maybe you could also speak to, although this was not part of the question, that maybe a little bit more about blending.
Sure. Yeah, great question, and one that is probably very challenging to answer today. When we think about blending hydrogen into our existing assets, right now we're targeting more of a 5, 10, 15% type of blend. If you look over at Europe, some of the most aggressive pushes have been in the 30% range, especially when I'm specifically referring to like long haul transmission pipelines. At the distribution level, that answer is probably a little different. But for our assets that are, interstate, 1,000-mile plus type pipelines, they're a bit more limited today. I think over time that will change. And that's really why we're focused on what can we do right now to start that process, to really start understanding what are the near-term limits and how can we start to make sure that we can operate safely, efficiently, still deliver the energy that's required from our systems without negatively impacting our customers and have end-use impacts. And so, 100% maybe in the future, I'd say near term, we're trying to get to that 10, 15, 20% that we feel comfortable with. And I don't think that there's a blanket answer that you can apply to every asset. They're going to have their own unique characteristics, their own vintage of pipe, their own compression, their own MAOP. So I'd be very hesitant to say that there's a standard answer. I think it's going to be very asset and regional specific. But definitely something we're spending a lot of time on right now, trying to make sure that we can start that process and really grow it over time to be able to provide a more scalable solution in the future.
Great, thank you. Either Joe or any of the panelists, there's a question about what is the role of liquid hydrogen carriers like methanol or ammonia? I don't know if that's something that from an end use perspective might have some interesting perspectives. Joe?
Yeah, I can take a shot and others can fill in. I think ammonia or methane, other chemicals, I think that can be produced are going to have to be produced in a way that is, very low carbon intensity. So hydrogen is kind of the first step, right? Being able to get to the hydrogen, being able to make it available so that then you can either produce ammonia or you can produce other chemicals. And again, it's about that large scale. So hydrogen itself, in terms of transport and safety and all the different things you think about, those complexities change when you go to an alternative fuel. If you go to an alternative liquid fuel, that's something we're already, particularly in the transportation space, used to handling. So if you can utilize it that way, it makes it simpler for the infrastructure. But there's a lot of work that's got to be done in order to make that cost effective. And there's a lot of work, I think, being done, but that's another one of those things that's going to be a sort of a long-term effort.
Great, thanks. Maybe just one quick last question. What are the considerations right now for moving hydrogen by rail? Is it being done in the US?
I think this kind of goes back to what Joe said around, what are the most cost-effective and lowest carbon-intense ways to move molecules. And so I'm not aware of hydrogen by rail. I think it would be more of probably an ammonia play, but not something that I see as really a scalable solution long-term.
Okay. Looks like our time for this panel in particular is up. I just want to say thank you to Phil, Brian, and Joe for your participation. And if we have other questions, if you're still around, we may be prompting you to help us answer some of those questions. So, but thank you. And we'll move on to the next panel. So we wanted to also spend some time talking to you about projects and what are we doing either in the US and with some of our members like NG who can talk about some of their international experience in the development of hydrogen infrastructure projects. So we are going to move to that panel, and as part of that, we're going to hear from Peter Shirk, who is a board member for Wabash Valley Resources, which is a project in Indiana. And he'll speak to that and what they're looking at doing there. In addition, and as I mentioned, we're going to also hear from Kim Carnahan, who's the Direction for Disruption Technologies at NG. And then we're also fortunate to have Christine Wiley with us. She's the Director of the Hydrogen Technology Center of the Gas Technology Institute. So I just want to thank you all for joining us today, and I will turn it over, I guess, for you to go in that order. Peter, we'll start with you. Thank you.
Great. Thank you very much, Shannon. And appreciate you getting me going here. Yeah, so my name is Peter Shirk. I'm with a project company called Wabash Valley Resources. And we're going to be a hydrogen producer. So there's other members of the coalition that are on the transportation and consumption side. We're on the production side. And what we're doing is taking an existing piece of technology. Phil mentioned in the prior session how gasification can be used to produce hydrogen. And that's how we'll be producing hydrogen in the coming years as this project develops. The way we make this carbon free is through carbon sequestration. So our project is in Indiana and in geology that is conducive to carbon sequestration. So we'll be producing carbon-free hydrogen using gasification, and through the help and support that we've received from the DOE, we're actually also investigating through this development phase to see if we can blend with our solid fuels, biofuels, which would, in fact, as Phil described, make us carbon negative, which is really exciting. Now, the quantity of hydrogen we'll be producing is a normal industrial, like very large scale, like 1 million kilograms a year sort of thing. The market for hydrogen is going to be encompassing a whole variety of uses: industrial, transportation, potentially steel, agricultural. But in the meantime, we've actually determined that our best short-term use of the hydrogen is to generate power. And through working with turbine manufacturers, we've actually been able to determine that we can run standard configuration with some modification combustion turbine and generate power, grid power, about 250 megawatts of baseload power that we'll be able to provide to the grid, which is pretty exciting from a lot of perspectives. We're excited about it because it's, we think, a great business in a part of the country that really could benefit from additional low to zero carbon power. And it also helps demonstrate that as we try to decarbonize the energy industry in the US using existing technologies and even existing assets, there are gas combustion turbines all over the country, obviously. If we can use those and with hydrogen, with clean hydrogen, to clean up the grid, that's a fantastic outcome. So we're very excited about that. And I'll turn it to the rest of that group. Thank you.
Thanks, Peter. Kim, can I tee you up next?
Sorry, I was just trying to get a few slides up. Give me just 1 second.
No worries.
You see my deck?
Yes, we can see it.
Okay, great. Perfect. So nice to meet you. Thank you so much for inviting ENGIE to present today. We're really happy to be here with the Clean Hydrogen Future Coalition. As Shannon mentioned, I'm Kim Carnahan. I lead our US hydrogen project development, so I'm certainly very excited to be talking to this group today. Just a little bit of intro on ENGIE, because I often think that ENGIE is probably the largest global company that most Americans, at least, have never heard of. I certainly had not been focused on ENGIE before I started working for them. ENGIE is a global leader in low carbon energy and services. We're actually the largest independent power producer in the world. We're also first globally in microgrids, and cooling and distribution networks, and electric vehicle, second globally in electric vehicle charging stations, and on. We have over 160,000 employees in 70 countries, and a lot of employees in the United States as well. ENGIE Group is severely committed to decarbonization. We have one of the very first validated science-based targets under the Science-Based Targets Initiative for any energy company globally. Our new CEO, Catherine McGregor, announced a net zero target by 2045 not long ago, as well as a detailed plan in which to meet it. And we have more than halved our greenhouse gas emissions since 2015, inspired by the adoption of the Paris Agreement. So really focused strongly on decarbonization. ENGIE Group also made a strong shift towards renewables over the last decade. You might have, if you have heard of us, you might have heard that we originally were kind of a gas player, especially in Europe. But we have shifted strongly towards renewables. We now have 31 gigawatts globally. And in the United States, right now we have 3 gigawatts, but we have another 7 in development. So we are adding to our portfolio very quickly. And I emphasize the renewables piece because we are also a major global hydrogen. We're in the first stages of becoming a major global hydrogen producer, and we are only focused on electrolytic hydrogen produced from renewable energy. So the renewables business, especially our renewables business in the United States, will be kind of the backbone of our hydrogen business as well. And we are very excited to say that our new CEO just announced really ambitious targets for hydrogen last week. So By 2025, we aim to have 0.6 gigawatts of hydrogen capacity globally. By 2030, we're hoping to get all the way to 4 gigawatts. So that's a really aggressive target. It's one that I can say from experience. You know, a week ago, I was told I should only develop projects greater than 10 megawatts, and now I'm being told that we should be looking at 50. So we are really expanding our focus on hydrogen development. But we actually are already really advanced in hydrogen projects globally, even though we're just getting started here in the United States. We are looking specifically at setting up kind of industrial scale renewable hydrogen solutions for regional and global markets. And we're trying to pull together multiple applications, you know, for maximum decarbonization impact. So we're working in a lot of ports, we're working in the mining sector and chemical sectors, major industrial zones in various countries around the world, trying to hit as much, you know, get as many applications using our green hydrogen as possible. And the way we do this, I mentioned, we are a renewables provider. So we are kind of a hydrogen integrator. We look across the entire value chain of hydrogen and play with the various building blocks and the sensitivity of key parameters to hit the lowest cost possible. So we have proprietary software that we use to find out, you know, exactly where we should turn the dial to get the maximum output out of the electrolyzer at the lowest possible price. And here's just a quick snapshot of a selection of NG references along the renewable hydrogen value chain. And these are in various stages of development, but it kind of shows you that we have projects all over the world. In fact, there should be a project or a couple of projects linked to the US as well, but those aren't public yet. So all I can say is that we're very actively developing projects in the US as well, and we hope to be able to announce those soon. And I just want to give a few very specific examples of projects that I found particularly interesting when I first joined NG. The first is our Zero Emissions Valley project. It's in France in partnership with Michelin, as well as the local region in the area where we did the project. This includes 20 hydrogen charging stations by 2023. These are relatively small charging stations, and they actually have on-site electrolyzers. So this is a very different project than many of the other ones we have done, but it kind of shows that you're able to produce and use hydrogen on site at many different sites in one specific region. And as a part of this project, we're actually working with our partners to put 1,000 hydrogen vehicles into circulation and hydrogen buses from the local region, as well as light vehicles and vans. The next project, our grid project, is of particular interest because I know, and some of the previous speakers spoke to this, there's a lot of interest in using green hydrogen or low carbon hydrogen to decarbonize the gas system, especially in the United States. And we have actually done a project in a residential area in France where we set up a blending distribution or hydrogen blending system as part of our natural gas distribution network for residential neighborhoods. So we actually started with a 6% hydrogen blend in June of 2018, moved to a 10% blend since March of 2019, and we actually reached our 20% target in June 2019. So we have blended in a residential area all the way up to 20%. And then the final project I think I'll look at here is our URI project. This is a co-creation of the world's first green ammonia production plant in Australia. We actually just received around a $45 million grant from the Australian government to make this project operational. So while we were waiting for that funding, we now have it and we're ready to kick off. This was really kind of a soup to nuts project for us, working very closely with Yara, the ammonia producer. So we have, basically done everything from the very beginning of the project inception, figuring out, how the project would be developed, what we would use to power the electrolyzer, it's going to be solar, and how to integrate the production of the hydrogen with the production of the ammonia. So this is another really very cool project that we're hoping to see actually break ground very soon. And I think I have a lot of other examples, but I'll stop here. And if there are any particular questions about project types that you'd like to hear about, I'd love to jump into more examples.
Great, thanks, Kim. I appreciate that. We'll get to panel questions in a few minutes, but please make sure that you're posting questions as they come to you. Christine, I'm going to turn it over to you now. Thank you.
Okay, great. Let me just share my screen here as I have a couple slides to share. And just checking to make sure that everybody can see the slides.
We can.
Okay, wonderful. Okay, so thank you so much, everyone, for having me. I'm really excited to share some of the efforts that we have going on and some of the projects that we have within the hydrogen space today. So I think what we're seeing from all of the panelists today is that a lot of us are aligning around really the shared vision that we have for what our energy future is going to look like, where we're really driving towards this low carbon future. One that is really going to, encompass, our energy system where we have multiple forms of energy, whether we're talking about electrons or whether we're talking about clean molecules. So I think that, we very much appreciate that we need to have an array of solutions to be able to, and are you guys seeing the full screen or which screen are you seeing? I'm sorry.
So we're seeing what looks like the PowerPoint presenter view. That's what it's.
Oh, okay.
It's not.
Yeah, sorry, I'm having some problems with my screen there. Is it full screen now, Shannon?
It sure is. Yep.
Okay, great. And so, we're very focused on, identifying multiple pathways and solutions and technologies that are going to help us achieve, our very ambitious and aggressive goals as we strive for a net zero type of scenario. One of the key solutions that we think we want to focus on is, how do we integrate hydrogen into our energy system? How does it become a solution to be able to decarbonize different parts of our economy, different sectors within our economy? So I'll focus on a couple key projects that we have at GTI, but then I'm also going to talk about kind of this concept around developing these hydrogen hubs. So I think there's a lot of interest around the creation of these hubs. We're starting to see that develop in places such as Europe, but then also through some early efforts through DOE's H2 at Scale program. So when we talk about hydrogen, we think it's going to be one of the solutions for our path towards net zero. But what we want to do is make sure that we're keeping a couple key elements top of mind. So we want to keep the customer top of mind. We want to make sure that we're doing and developing solutions cost effectively. We want to have flexibility and reliability and resiliency in the solutions that we're delivering. So really, this concept around developing these hydrogen hubs is going to be critical to advancing hydrogen as a part of our energy economy. And we want to be able to do this economically. And it also enables us to really have this global competitiveness when it comes to developing these low carbon solutions. I think we can appreciate that we're going to need different energy solutions based on where we sit within the U.S. Based on the geography, based on specific customer needs and energy demands. Those regional differences are going to play a part in the type of solutions that we develop. And I think we also appreciate now that a lot of these decisions are being made at the local level. So we need to be able to provide that optionality and that scalability when it comes to our solutions. And so we're going to focus on one of the key projects that we have in the state of Texas that is being awarded through DOE's H2 at Scale program. So we are very excited to be a part of this project. It was recently initiated. We are doing this in conjunction with Frontier Energy as well as the University of Texas, Austin. So in this project, we're going to be producing hydrogen through 2 conversion pathways. So one of them is going to be done through electrolysis, and then another where we're going to be using a small scale steam methane reformer, but the feedstock is actually going to be RNG. And so, in this project, we'll generate, I think, about a little less than 100 kilograms a day of hydrogen. And then we're going to store that hydrogen on site and then demonstrate the use of that hydrogen specifically in a couple key end use applications. So one is going to be to fuel an on-site hydrogen fueling station. And then it'll also be using that hydrogen to fuel a couple Toyota Mirais, as well as powering a 100 kilowatt fuel cell that's going to to provide backup power to one of the data centers on campus. And we're also going to look at potentially using hydrogen for drone applications as well. So a really nice demonstration of a hydrogen network more locally to the University of Texas Austin's campus. So another important piece of this project is actually conducting a feasibility study. So what we're going to do is to conduct a study around the Port of Houston, where we're going to look at the scale up of hydrogen production as well as hydrogen use. So really being able to assess, the renewables that are available, existing fossil fuel assets like natural gas, prospective hydrogen users, the delivery infrastructure that is already in place around that port, such as existing pipelines. So, in this study, we're going to model kind of the growth of what that hydrogen economy could be specific to Texas, while we're assuming kind of variations in technology and policy and economic options. I think, the Gulf Coast is already a base for hydrogen. I think we can acknowledge that. It produces probably about 1/3 of the total hydrogen annually, and is home to, probably around 50 hydrogen production plants. And it is over, I think, 900 miles of hydrogen pipelines, as well as subsurface storage of hydrogen in salt caverns. So it's an ideal place to start developing a hub around hydrogen. So ultimately, what we want to do with this framework and really this Port of Houston study is to be able to enable industry to create their own strategic action plans for building hydrogen networks in other parts of the country, and then really helping to advance the role of hydrogen within our energy system. So another project that I wanted to touch on is a project that we're developing in my home state, so in Illinois, which is focused around a project for zero carbon power and hydrogen production. And so we were recently awarded an initial phase from the Department of Energy, where we're going to design essentially a demonstration. It'll contain a system that's going to produce hydrogen, and then also have underground storage of the associated CO2 that would be injected into geologic formations that are suitable for this long-term sequestration. So I think in some of the earlier remarks from the panelists, we talked about kind of the different ways to produce hydrogen. We're going to be using a key technology that GTI has developed. It is an alternative to your traditional steam methane reforming. So it is using natural gas as the input, but the very unique feature about it, and really what we see as the differentiator, is that it has inherent carbon capture. So, alternate to some of the traditional ways to produce hydrogen, you have to have that post carbon capture on the end, which can make it quite expensive in terms of the capital expenses and the facility itself. But because our design has inherent carbon capture in it within the process, we're able to reduce those capital costs and just the overall then levelized cost of hydrogen production, which I think is going to be a key factor as we start activating the role of clean hydrogen from using feedstocks such as natural gas. Within the project, we'll also have some above ground compressed hydrogen storage, which will be used for buffering, but then we're also going to evaluate storing hydrogen in geologic formations that traditionally are used for CO2 or methane. And I think that's an important element. I think Brian touched upon the importance of being able to leverage our existing infrastructure. And that includes not just pipelines, but then also all of our subsurface storage that we use for natural gas. And so while we have demonstrated that you can store hydrogen in salt caverns, there needs to be more validation and testing and investigation into using other types of subsurface storage, other geologic formations like depleted reservoirs or aquifers. And then the final piece associated with the demonstration then is using that hydrogen in power generation. So we'll be working with Mitsubishi Heavy Industry using one of their gas turbines that will initially use a varying blends of hydrogen with natural gas. But then over the course of the testing and operation then of the demonstration, we would want to be able to reach 100% hydrogen feed for the pilot. So the final piece that I will touch on is really around collaboration. So, I think collaboration is really going to be key when we start looking at, how do we deploy and develop hydrogen solutions at scale. Joe touched on one of the initiatives that we just started with our partners at EPRI, which is our Low Carbon Resources Initiative. So this is a global R&D collaborative, which is focused on advancing low carbon technologies in the post-2030 timeframe. So, what we've been hearing and what we've identified through some of our analysis is that we do have the tools and the technologies to be able to hit some of those interim kind of 2030 goals when it comes to decarbonization, using things like, more integration of renewables or, energy efficiency, electrification in use cases where it makes sense. But kind of that post-2030 timeframe, we need to start looking at other solutions, and specifically at these low carbon resources like hydrogen and ammonia and biofuels and synthetic fuels. So within this collaborative, we're working with industry. We already have over 40 members, over $100 million in R&D funding. But what we're doing is advancing these low carbon technologies so that they can be deployed at scale in that post-2030 timeframe. I think another key in collaboration or kind of public-private partnership that we've seen have success is the California Fuel Cell Partnership. So that's really a public and private partnership. It's focused around building the market for transportation applications. But another nice demonstration of how you can work together with government agencies as well as industry. One of the more recent ones that we're also participating in is the High Blend project that's being led by NREL. So that's a collaborative that is focused specifically on trying to assess the impacts of hydrogen blending on the pipeline system. So, we're working with the national labs with a lot of the companies on this call to really assess, what are those, material impacts on different types of pipeline materials, on different components within pipelines, so that we can leverage it for either blending or potentially in the future, looking at, 100% scenarios. So I think I'll wrap it up there. I'm looking forward to discussions and any Q&A here. Thank you.
Thanks, Christine. So we'll go ahead and turn it over to Q&A for this panel. We'll start perhaps with Peter. We'll go back to you. You had mentioned that you're looking at designing right now the potential to co-fire with biomass and achieve net negative with support of Department of Energy. What will it take in your mind for Wabash to go into construction and become operational? Are you looking at policy tools or mechanisms that can help you get there, or were you?
Sure. Yeah. So yeah, the support from the DOE has been great on sort of an R&D type of thing to do some studies just to see that if that feasibility works on the net negative. Whether it does or not, in either case, I think the ability to generate baseload carbon-free power is going to be something obviously we want to achieve, but I think it's going to be critical for the country at large to achieve. I think to do that, if we look at the really tremendous success of government support programs through production tax credits on developing the wind industry that we have today in the U.S. is pretty remarkable, and was built on the back of those production tax credits, which were very effective at enabling the financing of those projects. And I think a similar, basically almost a copy of that same legislation to support all forms, not just wind or solar, but all forms of carbon-free energy would be tremendous and probably very necessary if we're going to achieve anything like we hope to at the scale and the pace that we need to. So that's, yeah, I think we need that. I think we've had some very encouraging indications from various legislators in the current administration. So I'm optimistic and hopeful that we will see that in some form in the near future. I think we will, and I think that will really hasten the development of projects like ours and many others across the country.
Great, thank you for that. This one is for Angie and Kim. question posed was, how does ENGIE plan to address high kilowatt hour fuel cell marine and rail applications with compressed hydrogen? The associated question with that is that associated with that is a comment that there are challenges potentially related to hydrogen storage and hydrogen volume requirements for those applications.
Can you say the question one more time? I think it seems, I want to make sure I answer exactly what you asked.
Okay. So how does ENGIE plan to address high kilowatt hour fuel cell marine and rail applications with?
Yeah. So I can't give you this, I am not an engineer, so I can't give you the specifics of how we solve those problems, but I can say that we have been a major partner for Alstom in Europe, in particular, in the development of their high-speed rail using hydrogen as a solution. So it is definitely something that we are working on very diligently. Same thing in the marine space. We have kind of two key partnerships, one with, I believe it's still an not yet named shipping company, where we're helping them develop the vessels that they could use liquefied hydrogen to run. And we're also working with a publicly announced partnership with Arion Group to actually develop next generation liquefaction technologies. So so that we can kind of get that liquefied hydrogen liquefied more efficiently, more cheaply, and get it more, have it be a more economic option for marine use. So sorry not to answer the super technical part of that question, but I tend to be more on the cost side.
Great, thank you. And maybe there's an opportunity for follow-up with that question. So, and then another question, I don't know if maybe, Christine, this is something that you've been looking at in any of your analysis through the LCRI or as GTI, but is there an estimate of the percentage of the energy consumed in the US that hydrogen could potentially encompass, say, in 2050?
Yeah, so that's a good question, and we're actually doing some modeling right now to assess that. So we have an integrated energy systems analysis that we're doing to identify different pathways towards decarbonization to reach net zero and what each element will play in reaching those objectives. So we don't have our results available yet, but I have seen some studies, one specifically from BNEF that has estimated, at least on a global scale, that in a very aggressive scenario, hydrogen can meet, I think, 24% of global energy demand. So that's just one reference point, but there are other studies out there that are kind of doing the same types of projections.
And in looking at those, projections, I guess, and because you just mentioned global, but from a domestic standpoint, will those be looking at what the potential export opportunities would be for domestic production?
Yeah, so I mean, I think that's an important element, right? When we start to think about kind of that economic competitiveness in this global arena. So if we talk about hydrogen and the ability to be able to kind of export it similar to LNG and maybe in ways where we're transporting it as ammonia, right? So we're looking at all of those solutions and pathways.
Great, thank you. Maybe one last question here, because I know we're running slightly over time, but it seems that hubs and the development of hubs are somewhat of a natural ecosystem approach to scaling hydrogen. And obviously you mentioned Texas, you talked about that. We heard about this Illinois project as well. Where do you see some of the other potential hubs potentially emerging throughout the country?
Yeah, so I'll let others chime in, but I think in the US, you could see it along some of the other coasts. So maybe around the Port of LA would seem like a natural fit as well. There's already a lot of work going on in that area, especially with aggressive goals that California has set with regards to decarbonization. But I might let some of my other panelists chime in as to their thoughts on where these hubs could develop.
Yeah, I would actually just agree with that. In addition to Texas and California, there's also a lot of activity in the New York and New Jersey region to consider the development of industrial hubs. So I think in the US, those are the 3 spots that are getting the most attention right now. But certainly in the future, we might see it expand to others.
Great, thank you. Let's see, one last. So this is one last question. What are the anticipated costs of producing decarbonized hydrogen? If anyone can answer that. I know we asked that on the last panel, but perhaps you all are able to do that.
I'd be happy to jump in. I'd say at least for electrolytic hydrogen, using primarily renewable energy, the prices vary pretty drastically across the United States, depending upon the cost of electricity in the region that you're developing the hydrogen in. So if you're working in Texas, it's notably cheaper than in California. The reason is it is partially about how much the actual energy, the electrons cost, but it is equally as much about how much it costs to use the electric grid if you are trying to use that grid at all. So the grid fees are the electricity delivery fees related to your project. Really can sink or swim it. It has been our experience. I would say, at the gate price of electrolytic hydrogen, what I've seen, I can't say what NG's prices are, but what I've seen in accurate, what I would call like accurate studies, is anywhere between a $4 and an $8 a kilogram price for the gate hydrogen. So that's not liquefied, that's not delivered, that doesn't include tax. That's probably around the best that you can get right now, which is why, as others have mentioned, that we're really hoping to see that production tax credit, put in place so that we can get that price down and actually increase the demand for the electrolyzers, which will help us drastically reduce those prices.
Yeah, I would agree with that range. I can say for our own project in Texas, DOE has set some targets in terms of being able to produce $4 a kilogram of hydrogen. So when we start looking at other options like, hydrogen from natural gas with carbon capture, I mean, typically I see that more in the, around $2, maybe sub $2 a kilogram range. So just to provide some context and perspective there.
Thanks, Christine. Peter?
Yeah, I was just going to echo that. Actually, I think in the really large scale where you've got economies of scale and you've got opportunities for carbon sequestration, you can probably get in that range in the plus or minus $2 seems to be likely. And I think because those resources are abundant, but also geographically constrained. That's why you do need to have a whole diversity of approaches, because as we know, the cost of transportation and such is difficult. So, as this market develops, we're going to need large scale, but we'll also need small scale local to service other needs. So that's why I think the whole range is necessary. And the cost alone is going to be dependent, as Kim says, on location. And application and scale and all the rest of it. But I think those numbers seem to be sort of consensus, and I would agree with it.
Great, thank you. I'll also just say, if you're looking for studies, Resources for the Future did a study at the end of last year. They published it in December. So it's at least a good start to look at some of these factors that go into the analysis and get just a blueprint of these numbers that you can reference. So
one thing I would say, if you don't mind, Shannon, I just add one final thought to that, because a lot of the studies are very, very good, but they often don't take into consideration all of the additional costs that it takes to get, kind of what we've been talking about throughout this entire webinar. It takes to get the hydrogen from the point of production to the point of use as well. They often don't include tax, which can add, quite a bit. And so we have customers coming to us and saying, well, why can't you produce hydrogen at X price? And we're like, well, we could produce it at that price, but don't you also want it like at your door to, so that you can use it? And that unfortunately increases the cost often quite a bit. So important to keep that in mind.
Very critical point. Thanks for that, Kim. So I want to thank you all as panelists for participating today. This is a really valuable discussion and really appreciate your time. We're going to turn now to the next part of the agenda. Well, in fact, we are unfortunately not going to be joined by Jim Brewer from the building trades. If we have time after we go to Neil Biup to talk to us about the policy needs to scale clean hydrogen. I can share a few words about the labor aspect of this, but before we do that, I'd like to turn it over to Neil. Neil is head of global government affairs for Lindy, and he also serves as our secretary and treasurer of the coalition. So with that, Neil, I'll turn it over to you.
Thank you, Shannon, and I appreciate it. It's been a really great discussion so far. And we talked, my colleagues here have already talked about a number of the points here that I want to raise, in the sense that, we're developing policy proposals as a coalition that I think reflects the diversity and the full scope of our group of companies here. But we are trying to get very specific and drive towards some very useful and productive input on the policymaking process in order to address directly some of the concerns that were raised today. And so, as Kim just mentioned, we know that the lower the carbon intensity, that the higher the cost of hydrogen molecules. And hydrogen is widely consumed today. There is, in fact, a market for it. But if we truly want to transition to a hydrogen economy, a clean hydrogen economy, there's just simply no question that clean hydrogen will need market transformation mechanisms to make the economics work, at least in the short term, until we can get to those economies of scale. And so to that end, our approach on developing policy recommendations really reflects our aim to promote technology neutral approaches to decarbonizing. But to be clear, this is with the ultimate goal of achieving zero or net negative emissions for hydrogen production. I think that's a shared collective goal and something we're striving to here. So we are working to develop recommendations that really work off of carbon intensity and in the form of a production tax credit, which was mentioned earlier, to encourage the production of clean hydrogen. Recommendations for federal grants for R&D and commercial scale demonstration projects that will help facilitate immediate or short-term investments to spur demand as well and spur production. We are working on demand side policy options as well, certainly in using hydrogen for electricity production, but we do think that we need to continue to explore opportunities to expand that into the other hydrogen application buckets, whether it be in mobility or in the industrial space as well, really to help establish a sustainable market for clean hydrogen. And that's really a really important point here. And then finally, I think something that was well covered as well, we are working on what needs to be done as a matter of policy to help establish a sustainable hydrogen infrastructure and distribution network as well. So our collective goal here is to advocate for these policies throughout the hydrogen value chain that sets us on that path to zero or net negative emissions. And being colorblind in this sense will allow us to decarbonize hydrogen production today as we build the demand for clean hydrogen in the future and achieve those economies of scale and help lower the costs for zero and net negative emissions. And so I think this is really an important point here with respect to being colorblind, because it really, as we see it from Lindy's perspective as a global industrial gas company, we simply have to do it in a manner that the market will receive, a manner that's cost effective, helps achieve significant emissions reductions in both the short term and the long term, and also helps transition really the entire economy here in the US into a new sustainable approach for mobility, for energy production and consumption, and certainly to continue to support our wide customer base in the industrial space as well. So we've been very engaged with policymakers in Washington, D.C. I know a number of us are engaged directly as companies, as part of the coalition. We're also very engaged with state and local policymakers as well, because there is a kind of a multiple track approach to all of these buckets where hydrogen can play a role, whether it be in the energy space, which of course has significant federal, regional, and state level regulation, as well as mobility. So we're very encouraged, I think, with some of the discussions we've had so far we are getting very positive feedback from both sides of the aisle on the role of hydrogen and the opportunity to transition in an economically viable and sustainable way, again, while significantly reducing carbon emissions simultaneously. So we will continue to flesh out these specific proposals and work directly with policymakers here, and hopefully we'll have some details to release fairly soon on our coalition-specific production tax credit proposal.
Great. Thank you, Neil. And thank you for sharing that information. One question that was asked is, what is the dollar amount of the production tax credit we're considering?
Well, that's a great question, and it really speaks to exactly the last point of the panel that was discussed, in trying to figure out a way to quantify the cost delta in a way that's actually, you know, meaningful to the existing and potential customer base. Really, in other words, that's meaningful to the marketplace itself. And there's a lot of variation there. So it scales based upon the carbon intensity, potentially. Those are some of the ideas we had as well. But I think one of the challenges that we have had as a group is trying to determine what amount is actually going to move the needle. And I think that is kind of a variable we have here still. We're right now, I think, Shannon, correct me if I'm wrong, but still soliciting some coalition member input on that point. Obviously, we can't account for every variable cost that's out there. And as Kim correctly pointed out, they vary from region to region. And for us, as an example, where we, as Lindy, supply hydrogen as a product, we supply hydrogen services and technologies. It is different based upon where we are and where we're located and what the demands of the customer are. So that is the key point here. There isn't one answer for that question, and we continue to deliberate exactly what the right price point is. And it's probably going to be, to some degree, an iterative process, and it may be something that evolves over time as the market starts to mature for this, and we start to get a little bit more demand, but also a little bit more market intelligence as to what customers are willing to tolerate there.
Great, thank you for that. That was actually really well said, just in terms of how to capture that from a policy standpoint can be challenging. You had also mentioned the need for, sort of stimulating demand in the end use markets and our efforts there. There's one bill that's been introduced that we support. Can you just, as one potential application for the PTC, do you want to mention that?
Are you talking about High USA? Yeah, we are supportive of this. The Hydrogen USA legislation that's been introduced that would add low carbon hydrogen to the Section 45 production tax credit for electricity produced from hydrogen. That is clearly a great opportunity and a great application for hydrogen. We've provided some input on that bill and have been supportive of that, and will continue to be supportive of that as an end use. And that's, but not to say that we won't continue to seek other opportunities to find policy approaches to increasing demand in the market, because achieving those economies of scale is going to be very critical to getting the ability to transition to a clean hydrogen.
Great, thank you for that. So thank you. I don't see any other questions for Neil. And maybe we can just end this session with a couple of things. One is I can maybe just speak to, in the absence of the building trades being able to participate today, and as a member of the coalition, along with some other labor unions that include the International Brotherhood of Boilermakers, as well as the International Brotherhood of Electrical Workers. First off, I guess the coalition really recognizes that, and the membership recognizes that union labor is going to play, sort of a critical role here, and standing up and transitioning to a clean energy economy. The industries that are represented in the hydrogen value chain already possess much of what the needed infrastructure is going to be supported by the laborers that really have a proficiency across the value chain, and that can help accelerate the transition. And this is widely recognized. some of the registered apprenticeship programs that the labor unions offer will really underpin the skilled workforce that is going to be necessary to really stand up and scale a hydrogen economy here in the U.S. So they're an important attribute of this, not just this transition, but in standing up a hydrogen economy here in the U.S. and are very excited and really supportive of this hydrogen transition. So with that, Michelle, I would love to be able to turn it back over to you. I don't know if you've been able to figure out how to make Shelia's video work, but if so, would love to see it.
Absolutely. Well, thank you very much, attendees and panelists, for putting together such a great webinar. We're looking forward to seeing what the Clean Hydrogen Future Coalition, love seeing your journey and seeing how we can transfer over to colorblind hydrogen. I think that's a really great message.
That was great. Thank you, Michelle. And thank you, Mike, Alex, and Shelia for inviting us to participate today. And we look forward to any follow-up or outreach that we can continue to have in collaboration with you all.
Thank you all very much.
And thank you as well. Great program and great group you all have assembled, and looking forward to watching the progress. And great timing as well. Have a great week, and we'll see you soon.